Idaho Technology Council here, and a special welcome to Bill Inmon. We all came to talk with and listen with. Appreciate him traveling. With that, I'll introduce Mike Magowski, my friend from Treasure Valley Data Enthusiasts.
Thanks. Hi, can you hear me okay? All right. Well, thank you, and thanks for showing up today. We're excited to introduce Bill. We've been meeting as the data enthusiasts. It was the Treasure Valley, actually it was the Boise Data Governance Group, and then we had a Treasure Valley Data Vault practitioners group, and we decided to merge those two a few years ago, and then COVID happened, and we stopped meeting in person. We've been meeting online every month since, and you're welcome to reach out to me or to TVDE, Treasure Valley Data Enthusiasts, at infovia.com, and we can put you on that list. But we meet about once a month and bring in folks that can help us with data management of all aspects, from data governance all the way to data warehousing. And so it's my pleasure today to introduce a recent friend of mine. Bill and I met a few years ago at a conference, and then we met again the other day, and I said, would you like to come and speak to a group in Boise? He said, sure, I'd do that. And so I have the privilege of spending the last 24 hours or so with Bill. We went out to dinner last night, and I found out that his mom calls him Billy, but nobody else can. His friends call him Bill. His mom called him William, but only when he was in trouble. He's written 65 books in 40 years. The first when he was in the early 30s. So I did the math. That's one every 8 months, consistently for 40 years, and then a few. Got a couple dogs, and he's taken to our puppy, my wife's dog, at our house. And he and I agree that we take precedent in our household, our wives first, then the dogs, then us. Right, Bill? So, and when Bill writes these days, he writes about his dogs. So it's kind of fun watching that at the end of his writing. So with that, I'd like to welcome the father of the data warehouse, Bill. Welcome, Bill Inmon, to the stage. Thank you.
Thank you, Mike. First off, it's an honor and pleasure to be here. I enjoy talking to groups such as yourself. I do it in many places all over the world, today with Zoom, but I enjoy this. And so first off, I want to thank you for inviting me. I hope to make our time together useful and interesting time. I want to begin today's conversation as kind of an adventure that if you turn the clock back when it comes to data in our corporation, not that many years ago, data was defining fields in some kind of structure. It was simple. And then we started to have database structures. Then we started to have online database structures. Then after online database structures, we started we had a problem. One day we woke up and we had all of these databases over the corporation, and we didn't know what the right data was. It wasn't a matter of getting data, it was getting data that you could believe, which is a different story than just getting data. And so anyway, we woke up to that point in time. That's the point in time where data warehouse came into being, because data warehouse was able to give you the answer to what is my enterprise data. A long time ago, the very origins of data warehouse were, I was at a company called Aetna Life and Casualty in Connecticut, and I was talking to the head of IT there. And the head of IT, a guy named Joe Guglietta, said, Bill, he said, I've got 10,000 programmers out there. And literally, Aetna had 10,000 programmers. And he says, I can't answer the most basic question. I can't tell you how many insurance policies Aetna has. And Aetna, that's what Aetna does. They're an insurance company, and they have policies, and they don't know how many customers they have. They don't know how many policies they have. They don't know how much money they're making. I mean, it was wildly out of control. And that was the genesis of data warehouse, answering the question from an enterprise perspective, not from a local application perspective, but from an enterprise perspective, what data do we have in the corporation? And now that turns out to be, as you're probably familiar with, a complex question, because answering that question is not easy in anybody's world. Some worlds it's worse, some worlds it's not as bad, but it's never easy. So anyway, that's where data warehouse came from. And then the world rocked along. Then we had big data. Then we had data marts. Then we had Hadoop, and we had a whole bunch of things that are going on out there. And today we wake up, and we have a different world today. We still have a need for understanding the enterprise data of the corporation. Believe me, there's good, valid reasons why that's the case. But in today's world, we have different kinds of data. You see, when data warehouse started, data warehouse was nothing but a world for structured data. Now, it was never meant to be that way, but that's just the way it was. And so data warehouse was good for transactions and transaction processing data. And it sounds good, that's reasonable. That was yesterday. When we wake up today's world, we still have that structured data. It still presents us challenges, but there's other kinds of data that are out there that have other characteristics. There's textual data that has got a wealth of information that nobody is tapping. There's analog IoT data that's being generated by machines that also have a wild amount of value as well. And so about, I don't know, a year and a half ago, out of the clear blue, I got a phone call from a guy named Ali Ghodsi. I don't know if you know who Ali Ghodsi is, but he's the CEO of a company called Databricks. And he said, Bill, he says, I was a professor at Berkeley, and we used to use your books. I'd like to chat with you. And so anyway, I started talking with Ali, and first off, he's a nice guy, but I started talking with him, and Databricks. By the way, I don't work for Databricks, in case anybody's interested. I really don't. But Databricks said, Bill, he said, we recognize that there are these different kinds of data in the world today, and we need to have a data warehouse for the different kinds of data. And so that's where this thing called a data lakehouse came from. The Databricks was the people that invented data lakehouse, and then Ali asked me if I would be the person to put an intellectual framework around it, like I did around data warehouse. And so I said, sure, be happy to do that. And so anyway, I want to talk with you today. If I can find how to move around here, I want to talk with you today about the evolution of where we have been and where we are going. Okay, yeah, I've got it. I usually screw these things up. So anyway, I want to begin with the proposition that we have all data in the corporation. This little orange line we see here, that represents everything you got in your corporation. When you look at everything you have in your corporation, what do you find? You find there's essentially, there's more than this, but essentially three kinds of data in the corporation: structured transaction processing type of data, textual data, and analog IoT data. And that probably covers the waterfront of 90-some-odd% of the data you'd ever find in a normal corporation. Okay, now I did screw it up. Let's try this again. Okay. Okay, I knew I could screw it up. What am I doing?
Worked yesterday, right?
It worked yesterday. working a minute ago. Let's try that. There we go. Okay, thank you. Okay, so what we find is when we take a look at data, data is not data is not data. Data is data, but when we take a look at the properties and characteristics of data, we find that it's actually quite different. That transaction structured data has different properties than data in text, and text has different properties than data coming from an analog IoT environment. In fact, the differences are so stark, it's like the Earth. If you were to prepare for a trip, to Antarctica, you would wear one kind of thing. If you were to prepare for a trip to the Sahara Desert, you would wear something else. If you were to prepare for a trip in the Amazon, you would wear yet a different kind of clothes. And so even though the Amazon and the Sahara Desert and Antarctica are all parts of Earth, they believe me, they are about as different as you can ever imagine. And so so it is with data. Data in the corporation, it may be data, but it is different. And it has different properties and different characteristics. So if we're going to have an architectural framework, the lake house that takes into account these types of information, this is what we're dealing with here, different types of data. Now, just in case you're not familiar, you're probably more familiar with this than I am, but just in case you're not familiar, what is our structured transaction-based data? It's data in which we find things like keys, attributes, indexes, records. We find them coming from bank transactions, point of sale transactions, telephone calls, payments made, etc., and so forth. And every time somebody does a business activity, they generate one of these transaction-based records. The reason why we call them structured data is not that the data is all the same, it's that the structure of the data is the same. Because when I go into Walmart and make a purchase, I get a record of me, the date, and the item that I paid. When you go into Walmart and make a purchase, you get a date of what you purchased and the date you made it. So the contents of your record are different than the contents of mine. But the structure of your record at Walmart is exactly the same as mine. So this is where the term structured comes from, and this is what we mean. Now let's go off over to a world that most people don't know much about, but ought to know a lot about, and that's the world of textual data. In the world of textual data, first off, there is a mountain of opportunity waiting for you in textual data. I liken textual data to California in 1848. The historians tell us that in 1848, you could walk down to the stream and pluck gold out of the stream in California. And then in 1849, they discovered gold in California, and you could no longer do that. Well, in today's world, the world of doing textual analytics, which we're going to talk about, the world of textual analytics is pregnant with possibilities that nobody's looking for. And so I have several college students ask me, says, Bill, when I graduate from college, how should I go look to make my career in technology? And I said, listen, if I were you, I would go into understanding text. Why? Because nobody's looking there, and because there's a wealth of opportunity there. And so what kind of opportunity do we find with textual data? Well, medical records, that's one of them. The electronic healthcare record is full of possibilities. Don't get me started on medical records, because they're a special case. Okay, I'll say a few words. If you were to take a look at the words in the English language, it's estimated, first off, nobody knows, but it's estimated that there's 660,000 words in the English language that are used. Of those 660,000 words, 600,000 of those words are medical terms. And my wife happens to be a doctor, and she's got this dictionary. And I'm going to tell you right now, you can randomly open up any page in that dictionary and find words that are legitimately words. You got no idea what they mean, unless you're a doctor, of course. And so when we start to do textual analytics and start to talk about medical terms, that's a special case just because of the vastness of the number of words that are there. But that's not the only place where there is opportunity when it comes to text. In terms of hearing the voice of your customer, listening to people on call centers, listening to people on the internet. I don't have time for some of my stories, but I've got some very interesting stories about what happens when you don't listen to the voice of your customer. And so there is great opportunity out there waiting for you if you start to unlock. Now, is text easy? I didn't say text was easy. Why is text hard? Text is hard for one reason. Number one, it's complex inherently. Number two, as every one of us was a little child, we learned language. And what did we learn when you learn language? You learn rules. You learn rules of spelling. You learn rules of meaning. You learn rules of expression. You learn rules of punctuation. Your head is filled with all of these rules. And then as we as adults grow up, as we're listening now, your brains are in the background processing thousands of rules and you don't even know it. And it's just you do it subconsciously. But when you have a computer that needs to start to do textual analytics, those rules don't happen automatically. You've got to now put those rules in the computer. So that's just a little glimpse into, there are other reasons too, by the way, why text is difficult. For one thing, there's lots of languages. English is a great language, but folks, I got news for you. It ain't the only language out there. Another thing, there's what's called formal language. There's what an author will write formally in a book, and there's slang, and there's doctor's comments, and there's acronyms. There's all kinds of variations and exceptions that make language extremely difficult to deal with. That's the obstacles that are waiting for you. The reward waiting for you is once you break into the gold mine is full of gold. But getting there and getting through the obstacles is not an easy thing to do. Textual data, in case you don't know it, there is technology out there, and I'm not going to dwell on this, I'm just going to mention it. Technology that can take textual data, put it into the form of a structured database so that you can do analytical processing for it. So if, for example, you have medical records, you're able to take those doctor's notes, take the doctor's notes and find out and organize what the heck the doctor is saying. But you can do the same thing for internet data, call center data, contracts. Contracts is kind of an interesting case. When we first started doing what we did, we started talking to people about contracts. I can't tell you how many corporations I've asked, okay, Mr. and Ms. Executive, you're an executive here. Oh yeah, we're an executive here. And I said, can you tell me what is in your corporate contracts? And to date, not one executive has ever raised their hand and say, oh yeah, we know it's in our corporate contracts. Executives don't know what's in their corporate contracts. And then I say, well, I guess I'm kind of confused because you are an executive here. Oh yeah, we're an executive. You are in charge of liability. Oh yeah, man, we got risk management and liability. We got that code. I said, well, gee, I'm kind of curious then. You tell me you have risk management and liability knocked out, but you don't know about what's in your corporation, in your contracts. Don't you think there's liability in your contract? And that's a stupid question because that's what contracts are for. That's one of the reasons what contracts are for, is to manage that liability. And at this point in time, don't get me started on this subject. But it frustrates me no end that executives fool themselves into thinking they know what's in their corporate contracts when in fact they don't have a clue. So the third kind of information we have out there is machine-generated information. There's all kinds of machine-generated information that's out there. There is electronic eyes, there are temperature gauges, there are speed monitors, there are drones in the sky. There's all kinds of machines that are out there. You may not be aware of how much machines sit there and monitor you and your family, but you ought to be aware of it. So that's the third kind of data there is. When you talk about the properties of machine-generated data, I tell people think like a surveillance camera. Now you stop and think, what is it? Suppose you've got a surveillance camera in the parking lot of your company. What does that surveillance camera see? What that surveillance camera sees is 99.9% of the time, they see nothing of interest. They see a parking lot, they see an empty parking lot, they see people parking their cars, they say people lubing their cars, and it's absolutely unuseful data. However, 1% or one tiny percent of the time, they see a wreck, they see somebody stealing the car, they see some incident in the parking lot. And so the vast majority of the information you get when you are looking at a surveillance camera is, from a percentage-wise basis, 99.999% of the data is essentially useless data, and 0.0001% is extremely interesting and useful. And so that's the nature of the type of data that we find when we are dealing with machine-generated data. That's what we mean by analog IoT data. Now, a while back, and I'm not going to name, I don't know, I'm prideful of not knowing who did this to our industry, but somebody, I don't know who, came along and said, oh, you know what we need to do? We need to take all of this data and throw it into something called a data lake, and then people can come along and do analytic processing out of the data lake. And this is what our industry was told, and to the amazement of me is people in the industry actually believed it, because what happened? In short order, the data lake turned into a data swamp or a data sewer. All of a sudden, people found out that, gee, you know, we've got this data here. We can't do anything with it. We can't analyze it, and for 100 reasons. And so this idea called a data lake, and I don't use the word stupid lightly, but it is a stupid idea. And again, I don't know who I'm insulting. I'm somebody out there I'm insulting, but that's what happens for when they get for having an amateur do data architecture, because taking your data and stuffing it into a data lake and hoping something good happens for it is like Alice in Wonderland. So the data swamp and sewer was not good for anyone. And the worst one I've run into, I'm not going to name the name of the company, but there's this one company that I know of that last time they told me they have 3 petabytes of data in their data lake. And do you know, first off, how much that's costing them? Number one. And number two, do you know how useless? They can't find anything. Have you tried to ever work your way through 3 petabytes of data of anything? And lots of luck. And so what happens is we need to do something to turn these structures called data lakes into something useful. If we don't, we are wasting our opportunity, we're wasting our company's money's time, we're wasting our career. And I don't, none of those are good, I don't think. And so what do we need to do to take our data lake and turn our data lake into something that is useful, not the data lake that we have today? Well, we need to do 2 things, and we're going to discuss these 2 things. We need to create, number one, an analytical infrastructure. And you say, okay, Bill, I need to know more about that. And number 2, we need to make sure that the data that we put into the thing called a data lake is going to be integrated, vetted, useful, edited data. We don't need to just take data that is willy-nilly, God knows where it comes from, and put it into our data lake. So those are the two things that we need to do. Now, are these things easy? Are you going to do them overnight? No, I don't think so. But that doesn't mean they don't need to be done. So in doing so, we take our data lake and turn it into the data lake house. By the way, I was at a conference the other day and somebody said, gee, Bill, this terminology is confusing. Data lake house. I didn't make the terminology up. Data lake house was given to me by our friends at Databricks. Data lake, I don't know where data lake came from, but it appeared. But I didn't make the terminology up. So don't blame me for that. I've done a lot of things in my life that you can blame me for, but that ain't one of them. So who does all of this apply to? It applies to, first of all, everybody that does analytic processing in the corporation. However, the person that this most applies to is the data scientist. That we have these people out there that go to school, that learn all about statistics and algorithms, and which is great. And when they come into the real world, they find out, oh my gosh, all this stuff that I learned in school, I can't use. And why? Because I don't have the data to operate on. So we turn our well-educated data scientists into data garbage men. They're people that they spend 95% of messing with the data before they can ever get around to doing data science. That's the person that's most hurt by this inane idea of a data lake. So the first thing we need is something called an infrastructure, an analytical infrastructure. Let's take a look at what we mean by an analytical infrastructure. And in order to explain the analytical infrastructure, I want to take you to a library. How do you find a book in your library? You go down to your local library here in Boise and you want to find a book, I don't know, some kind of book, and do you walk in the library and start going from stack to stack of the library? The answer is, if you do, number one, you're probably never going to find the book you're looking for, and if you do find it, it's going to take you a week to find it. It's going to be a really stupid exercise to walk in the door and just start looking for a book. Only if you're extremely lucky are you going to do that. What do? Instead, you go to a card catalog. You go to the library card catalog, you search through the card catalog efficiently and quickly, you find out where the book you're looking for is, and then you go to the stacks, and in such a fashion, you can easily and quickly find your what you're looking for. That's what we need for our data lake. We need a card catalog that tells us how to find our way through the data lake. And so that's the essence of the infrastructure that we find. And so that's what we're looking for. Now, when it comes to what the contents of that analytical infrastructure look like, it's another story. And when we get into the analytical infrastructure, we find that it's actually quite complex. Why is it complex? It's complex because the data that it points to is very different. That the kind of metadata that you need to look at structured transaction systems is very different than the kind of metadata that you need for looking at text, which, by the way, is yet even different from the metadata that you need to look at for your analog IoT environment. And so it's not surprising then that when we look at the analytical infrastructure, if you think it's a piece of cake, you're wrong. It's not a piece of cake. Because you've got things in there, some of which you're probably familiar with, some of the things which you're probably not familiar with. You've got data models, you've got database design, and that's good, that's interesting stuff, and it's useful, you need it. You've got ontologies and taxonomies, and most people don't know their first way around an ontology or taxonomy. You've got something called inline contextualization, which you probably never heard of. When it comes to the world of analog IoT processing, you've got distillation algorithms and a whole bunch of things that, quite frankly, are very, very foggy in your mind. But that's what you need in order to be able to bring together the different kinds of data that are in the that are in your data lakehouse. And the second issue you have is the actual loading of data into the data lakehouse. Now, when it comes to transaction-based data, you do need classical ETL to load in your application-based data to put it into the data lake. I'd like to point out that when you build your data lake, if all you are building is a structured textual structured environment, then your data lakehouse looks exactly like a data warehouse. There's no difference between a data lakehouse and a data warehouse if all you're putting into it is transaction-based data. The second kind of analytical work needs to be done to your data. If you're bringing raw text into your lakehouse, you need to do an analytical conversion of the data. You need to do textual ETL to be able to put your data into a form. You don't want to put raw data into your data lakehouse. The third thing you need to do is you need to be very clear and obvious about what your distillation algorithms look like. And you need to have them documented, and there's a lot to be said about them. So that's what you need to do. Most people are not familiar with textual ETL. Textual ETL is technology that contextualizes your text before you put it into your data lakehouse. And so, again, you don't want to put raw text into your data lake. There's about 100 reasons why that's really not a good idea. Okay, machine-generated data. The data that most people, not all, but most people are not familiar with is machine-generated data. And in machine-generated data, you want to take your data that has a high probability of access and separate it from the data that has a low probability of access. In other words, if we were one of those surveillance cameras, we want to take the data that is the mundane data of the parking lot just sitting there. We don't want that cluttering up our environment. We want to go in and find the data that is of value and use to us, and that's what we want to put into our data lakehouse. So here we see that we found some data that the robbery took place at 6:31 a.m. on Tuesday, and there was a 3.5 minute worth of tape. We certainly want that. An accident occurred at 5:15 p.m. on Thursday for 1 minute. We certainly want that, but everything else goes into the bulk storage or trash heap. Okay, now there's a couple of things as a data architect we need to be aware of. One thing we need to be aware of is the fact that the volumes of data that we find are not equal. That there's under no circumstances is your structured data in terms of volume the same as your textual data. There's usually a lot more textual data than structured data. And then the same is true for machine-generated data. There's usually a lot more machine-generated data than there is of anything. So what we need to do is we need to separate, and this is where the art comes in to this, we need to separate the business value data from the non-business value data, because we don't want that non-business value data getting in the way. And we can see that when it comes to transaction-based data, that there is most of our transaction-based data does have business value. Some of, or a good portion of, our textual data has business value, and very little of our machine-generated data has great business value. So what we want to do is to separate that. We want to take the data that has low or no business value and put it off into bulk storage or the trash can. We want to take the data that has great business value and put it into high performance storage. And now another thing we can do is, on the occasion where we find data that happens to find its way into bulk storage that is necessary, we can bring that data forward into high performance storage. Another thing we need to do is another practice to manage our data lakehouse environment is to periodically archive data off. I don't know if I'm sure you are aware of the fact that over time, the value of data diminishes. And you take data and let it sit there long enough, and you're going to wake up one day and it's not going to be worth anything. And so, and we don't want that data that's not worth anything cluttering up and making inefficient operation in our data lakehouse. So we need to archive that world. And when we do that, we make sure that when the data scientist goes to use the data warehouse, the data lakehouse, that the data scientist is now operating on fresh, useful data where other data doesn't get in his way. That's how we make our data scientist a happy camper. One of the questions that I always get asked, is traditional at this point in time, is, gee, Bill, can you tell me again what the difference between a data warehouse and a data lakehouse is? And so let me try to make an analogy for you. Suppose you have two cousins, to a young man, an 8-year-old young man and a 7-year-old young lady sitting in the room, and they're cousins. Their parents are related. And so they're sitting in the room. When you look at the young man and young girl, you can tell they have facial features that are the same, hair features, body characteristics. It's very clear that these two children are related to each other. On the other hand, if you did a DNA analysis and sample, it's also clear that these two people are different people. For one thing, one is a female and the other is a male. So genetically and DNA, they are not the same thing. But are they related? Yes, they are. And that's the complicated relationship between a data lakehouse and a data warehouse, that there is this complex relationship between the two. So understanding this, now I've given you this, I'm an architect, and this is an architectural view of how things are playing out. And to me, it's exciting stuff. So when you do all of this, what do you end up with? You end up with a bunch of happy campers. Speaking of happy campers, I have some free stuff. Everybody around the world, I don't care who you are, loves free stuff. So number one, there is a book that if you're interested in textual analytics, you can get for free. All you have to do is to download it, to go to this website and look up ebook. And it's it's for free. The only thing we require is your email address so that we can send it to you. But other than that, there is no cost to it. And what with the book on, okay, I got to give you a little bit of background on the book. Textual analytics has traditionally been very complex to do. The universities started doing textual analytics many years ago, and they did it in a gruesomely complex fashion. So we did a commercial version of text analytics, and what you'll see when you look in the book is easy, fast, and inexpensive. Everything that the academic version is not.
Did you approve the subtitle?
Pardon?
Did you approve the subtitle?
Would-
They sneak that in after
Yeah, I did.
you approved it?
Yeah. So simple, even Bill Inmon can do it. Yes, I approved that. I wrote it, but so yes, that's a Bill Inmanism. Okay, the second thing we have is a prototype data architecture. Again, this is for free. We don't make any money off it. But if you're interested in taking your data architecture and comparing it to what we believe a high-level prototype data architecture would look like, you're welcome to download this from the website. And then the third thing, my publisher told me I have to put this up. There is a new book out there on Amazon.com, Data Lakehouse Architecture, and it's something that if you're interested in the subject, you will probably enjoy. So my voice is is getting shot. I don't know if it's old age or the dry. This is the first nice day I've had since October. I live in Denver, and it has been so cold. And we were sitting out on the Mike's porch today, and the sun felt deliciously good. I haven't felt warm like that since last October, and that's been what, 8 months ago. And so anyway, my throat is a little bit scratchy today. Apologies for that. Pardon? It felt good, Dave, Mike. Okay, I have time for questions. I have time for questions. I hope you've found this to be entertaining. Thanks. Sure.
Well, if we could keep the recording rolling, we're going to do the kind of a discussion format. And so the intent is for everybody to have a chance to ask Bill questions. And this isn't the only chance you get, because after this, we're going to walk across the street to the Ram. So for anybody who can join us, but we'd love to make this interactive. But before we jump into that, I want to thank, first of all, St. Luke's for hosting us, Rex and Daniel and Lisa. Lisa did a lot of work. Yeah, I really appreciated that. Beautiful facility here, and glad to have a place. Second of all, the Idaho Technology Council. So Jay and Paula, thank you for helping us promote it and fill up the room. So thank you. And this is also part of their Spark series. So it just turned out that the timing would work out for that, and so we appreciate the almost monthly content that Idaho Technology Council brings to us technically in that regard. And then finally, thanks for Bill for coming here, but not just to come to Boise. It was an easy flight from Denver, wasn't it?
Yeah, it was.
But really, Bill, I want to thank you personally for starting an industry that puts food on my table, that I've made a career out of, and so many of us others here. When you were in your 30s, I don't know what I was thinking about in my 30s, but I wasn't thinking about creating an industry. And you took the time and the effort to put your thoughts down on paper. And here 40 years later, we're still talking about it. So that is relevant and that is significant. Well, so I want to thank you for that. I'm honored to be sharing stage with you.
My pleasure.
So with that, Rex and I are just going to sit down with Bill and start a conversation. And when there are questions, Paula will bring Mike around, and feel free to raise your hand, and we'll take it from there. So Bill, you mentioned last night that you wrote your book. Speaking of your book, you wrote it out of frustration. Can you tell us a little about that journey?
I write books and articles out of frustration. I see something that I think is wrong with our industry, and not that I try to write it, but I at least try to explain it. And in the latest book that we have here is about artificial intelligence, machine learning, and data mesh. What drives me nuts today is these people walking around. There's nothing wrong with AI. There's nothing wrong with machine learning. What's wrong with it is the assumption that we have data that we can operate on. If you have unbelievable data that you are trying to operate AI on, guess what? I don't care how cool and how wonderful the AI is, you're not going to succeed. There's this foundation down there that's got to be laid. And the AI people, and I blame them, the AI people, the ML people, the data mesh people, they say, oh, you've got data. Well, guess what? You don't have data. And so anyway, the latest book is on what does that lower level of data look like? What does it take? Now, this is an ugly subject. This subject is a 4-letter subject, W-O-R-K, work, that is not, anybody that thinks that it's easy to build that foundation hadn't done it. And so when I was on my first book, I was working in San Francisco for Standard Oil of California. And working at Standard Oil of California was like working in an insane asylum where the lunatics were running the asylum. I've never seen such a crazy place. So one day,
Tell us how you really feel about that.
one day I wanted to save my sanity. I said, oh, this isn't right. And so I'd never written anything before in my life, never. In college, I avoided courses where you had to write. And so one day, for whatever reason, I sat down and started writing, and I wrote a book. And I was in a place called Livermore, California at the time. I had a fireplace, and when I finished, I thought, I'm going to burn this book. And I thought, no, I said, the worst anybody can tell me is this book's a bunch of garbage. And because I'd never written anything in my life. And I couldn't, to this day, I can't believe it. I got 5 publishing contracts from the major publishers of technology, and in hindsight, it wasn't a very good book. I, as a writer, am much more mature and much more organized and understanding how to write a book today, thank goodness. But at my first book, it wasn't very good, but for whatever reason, it hit a nerve. And then, so when I write articles, as I frequently do, or I write books, it's because I've seen something that, like AI, I think I don't have anything at all against AI. I think there's a great potential and value there, but I think that the people that are doing AI are doing a disservice to our community by not recognizing that if you don't have that foundation of data firmly beneath you, that's believable data. It's not a matter of having data, it's a matter of having believable data, then that's wrong. That's what motivates me.
We're sitting at St. Luke's here, which is the largest healthcare provider in the state. What you had an analogy last night to talk about the people curating the data and putting that in the hands of your most expensive or specialized resources, kind of like a doctor doing all the work in the hospital, right?
Well, I was a consultant for 2.5 years' time at a place called Mayo Clinic in Rochester, Minnesota, and they were trying to build a data warehouse. And the thing about Mayo and the medical profession in general, and I'm trying to say this with respect, I really am, but it's also the truth. The thing about the medical profession is, if you're not a medical doctor, you don't know anything. And they hired me on as a consultant to help them with the data warehouse, and then they were making technical decisions. And the technical decisions they were making were terrible technical decisions. And it's kind of like, I don't tell people how to do medical work, heaven forbid, but why is the doctor telling me how to run technical business? I'm just trying to help them there. And so we parted ways after 2 years' time. And the last meeting we had at Mayo Clinic, we had a room full of, 6 or 8 doctors, myself and some other people that were there. And we spent 8 hours talking about how 2 words were going to be treated. And I don't know, 2 medical terms. Couldn't tell you what they are today. And at the end of the meeting, I said, guys, this is all a very interesting exercise. But see this dictionary of medical terms? If it takes us 8 hours to understand how to treat 2 terms, our great-grandchildren are going to be sitting here doing the same thing, because we're never going to finish doing it this way. And that's when they got rid of me. And that's fine. I'll be honest, by that time I was happy to go.
So Bill, okay. I'm really excited about this lake house. I'm not sure who named it, but it's really exciting, and I appreciate you providing some context around it. For the last decade or more, we've heard the term data lake and kind of, yeah, data swamp. It's just going to throw your data and it's not going to make better. So really like that. But the problem we have today is everyone's selling a lake house, right? It's the term of the year, and everyone says, yeah, me too. I've got a lake house. What are as we start working on our data architecture for lake houses, what are those critical things we should consider technically to really formulate a lake house when someone says they have one?
Number one, spend some effort and time on the analytical infrastructure. If you don't spend time, I don't mean to threaten you, but if you don't spend time on your analytical infrastructure, you're going nowhere.
You mean that four-letter word, work?
Yes.
Okay.
And then the second thing is make sure that the data that you put into your data lake, don't just throw raw data in there. If you have application transaction-based data, integrate it and make it enterprise data. If you have textual data, take it and contextualize it and put it in. If you have analog data, take it and distill it and make sure you only put in the data that's necessary. So don't treat your data lake like a garbage can, because that's what most people do. This company that I was dealing with in Texas that had nearly 3 petabytes. Do you know how much 3 petabytes of data is? It's more data than the stars in the sky. And I mean, and they wonder why they're not getting anything out of it. They're not very bright people, by the way.
I'm afraid to open my mouth now, Bill. Yeah, there's some questions coming in from here. I wanted to ask you, you know, that whole bunch of work that takes, and you just mentioned bringing in all these different sources. Is there a way that we can break that down and, so to speak, eat the elephant one bite at a time? Is there an iterative approach?
You absolutely should not try to bite it off all at the same time. That is death. And if you want to die, then go ahead, but that is death. So you've got to do it iteratively. Now, the way that people are approaching it that I think makes sense is from a business value standpoint. Where do I get the biggest bang for my buck? And quite frankly, that structured data is where most people have the biggest bang for their buck. On the other hand, textual data. Textual data is something that there's tremendous value that people have never looked at, that never even attempted to look at, and there's tremendous value in there. So my advice to you, first off, absolutely do it in an iterative basis, number one. Number two, do it from a business value driven standpoint. And number three, don't ignore your textual data.
You mentioned the business value, and I know we talked last night about the definition of a data warehouse, and you defined that in 1981 or two, right?
Yep.
And I asked you how many times it changed. So you can answer that, but the last 5 or 6 words of that is the whole value out of in support of management decisions.
That's right.
If you don't get to that point in your data warehouse or your data lake house,
I've done anything.
what have you accomplished? So,
You know,
and then that'll be a segue into one of the questions that we have from the audience.
from the standpoint of definition of data warehouse, I do not know where the words came from. I'm not smart enough to have done what I did. So one day the words magically appeared and I uttered them. Yes, I did utter those words, but the definition of a data warehouse, my definition, has not changed one word over these years. We got it right coming out of the gate. The definition of IBM, of Teradata, of SAP, of Microsoft, every vendor that comes along wants to twist the definition around to try to make it fit their technology, to try to fool you that that's a data warehouse. So that definition of data warehouse, that changes probably is 3 times while we've been sitting here in this meeting. But the original definition of what a data warehouse is has not changed one word in all these years.
All right, so we've got a question from the chat from Troy Hiltbrand. Can you explain a little more about what ontologies are and how they relate to the data lakehouse?
Surely. Ontologies are what we use to manage text. Ontologies are the moral equivalent to a data model, except that they apply to text, not to structured data. Ontologies have two definitions. They have a very academic definition that's very complex, and then there's the Bill Inmon definition. And we in the work that we do, we work with ontologies all the time. I don't run around talking about this or bragging it, but we probably know more about ontologies than anybody else. And why? Because we work with them every day. The Bill Inmon definition of ontology is related taxonomies. Let me give you a quick example of what I mean by that. Suppose I have a taxonomy for country, I've got a taxonomy for a state, and I've got a taxonomy for city. So in countries, I have United States, France, Britain, Brazil, Canada, wherever. When it comes to states, I've got Utah, Colorado, Denver, or Utah, Colorado, Texas, Arizona, and California. When it comes to cities, I have Boise, I have Denver, I have Dallas, I have El Paso, I have Phoenix. And so here I have 3 taxonomies. I have a country taxonomy, a state taxonomy, and a city taxonomy. There is a relationship between the elements of that taxonomy. I can say that most states have a country they're in, and most cities have a state they're in. So the working simple definition of an ontology is business related taxonomies. And I'm going to tell you again, you don't want to get me started on the subject of taxonomies because we'll be here for the next week, but it's a fascinating subject. Okay, let me tell you just a few things about taxonomy or ontologies. Ontologies have 3 distinct levels. They have the industrial level. The industrial level are words that are used in an industry. Medicine has their words, lawyers have their words, attorneys have their words, engineers have their words, teachers have their words. Every industry's got their own private little vocabulary, and that's good. The second kind of portion of an ontology is the generic portion, and this is common usage, where I say, I like whatever, I like oatmeal, I like marbles, I like football. It doesn't matter what I like, but the expression I like is generic. And words like I hate, I like, I love, and words like that. That's the second kind of element of an ontology. The third element of an ontology are the specific terms to a particular corporation. So Micron has a way of specifying part number that's known and used only in Micron. Nowhere that's in Silicon Valley, in Japan, and Brazil, they don't use that. It's Micron says when I see JPAQ352-1, I recognize that, aha, that is a specific part number. So when you look at ontologies, there are 3 elements to an ontology. There's the generic level, there is the industrial level, and there is the specific level. And you've got to have, if you're going to take raw text and start to take raw text and turn it into a useful database. When you build your ontology, you've got to have all of those levels. Now then you say, gee, Bill, aren't on these different industries, aren't there a lot of terms out there? And the answer is yes. Aren't there overlap between the terms from one industry and the next? Yes, there are. So it's a complex subject. Anyway, that's a little bit about ontologies. I'm thinking of having a course on ontologies. The problem with ontologies is the academics come along and confuse things. I don't know if you've ever seen the academic definition of an ontology, but convoluted is the word for it. Listen, we work on a practical basis with ontologies every day, and we know what we're doing, and we don't pay any attention at all to what the academics are doing.
So thanks for clarifying that. When you talk about we, there's a room full of data professionals here and throughout the industry, we have analysts and we have engineers and we have architects and we have BI developers and data scientists. Whose responsibility, when you say we, whose responsibility is it to define and implement that ontology?
You've asked a very, very sensitive question because ontologies are the key to being able to do large language modules, are the key to being able to do text analytics, and you're now asking me what we would consider to be a trade secret, and I love you like a brother, but I'm not going to tell you.
I don't mean to be. Yeah, I don't mean to be prying. I just mean like
No, I understand.
The we in the audience, everybody's thinking, at least I'm thinking, well, I probably could do better at that. But I maybe as the architect, I'm not as keenly aware of the business as the analyst would be.
Let me tell you a little story. When we started this, we've been doing, my small group of merry men, when we started doing this, we were back in about 2002, and we looked around to find books. We looked around to find out who else has done it, and man, it has been trial and error the whole way. And we had to learn everything that we had to learn the hard way through practical experience. When it comes to ontologies, are the dead bullseye secret to being able to do textual analytics properly, and we have the world's largest collection of. So we've got about 5 people that have been doing ontologies and understand it. And today, I guess it's like anything else in life. Once you've done it 5 or 6 times, you get to be good at it. You get to understand what you're doing. And we've got a couple of people that know what the heck they're doing, and they can do ontologies. You wouldn't believe how fast they can do ontologies.
I think the takeaway then is ask an expert. Don't go there alone, especially if it's your first time down that road or that path.
Are there myriad of paths you're going to go down? You're going to get lost on one of those paths, and especially. And I don't have anything against academics. I really and truly don't. I actually have an academic degree myself, but the academics have just made chop suey of that subject, and they will confuse you.
I'd like to make sure we give people in the audience. Is there someone in the audience that has a question? I know we're a little bit over time, but this is great.
All right. So I love this conversation about ontology. Fascinating subject. Please do write a book. But my question is in regards to what you were talking about is, I mean, wouldn't ontology be an emergent property of those industries or social groups or organizations rather than something you define?
You know, I'm hard of hearing. I'm an old guy and I'm hard of hearing in my left ear. I'm going to have to come down and listen to you. What was your question again?
So essentially my question is wouldn't ontology be an emergent property of groups or cultures or societies or organizations, industries, rather than something that you define?
No, no, they wouldn't. Ontologies are embedded in language, and it's the very language and understanding that we have. And the thing about a data model, you go into a corporation and they say, this corporation is defining revenue this way, and that's all interesting and whatever, good. You go into language and you find out in language that general usage of a term is not defined by an individual or a corporation. It's general usage. And ontologies, they are what they are. You discover them and you codify them, but in terms of shaping them, you don't shape a taxonomy. And you shape a data model, you do not shape a taxonomy. And I wish I could show you some examples. And if you're interested, I'll be happy to show you some examples. But if you see some examples, you say, that's what he means. But ontologies are what they are based on common usage of the language. And to the best of my knowledge, there's nobody that tells us what common usage of a language is. Data models, on the other hand, are something that you do shape. You say, this corporation says this key means this, and this attribute means this, and so you can reshape it. You don't do that with an ontology. And I hate to be mysterious. I really don't mean to be mysterious, but it's hard to explain.
Yeah, I would definitely be interested in having a longer conversation about this.
That'll take 8 months to write that book, on average. So Troy says thank you online for answering his question. I don't think there's any new questions online. I haven't gotten any. Anything else in the room? We've got time for one or two more, and then we'll break and move across the street.
I'd love to know how this presentation might change 10 years from now or 15 years from now. I hope you're still around. I assume over time, as we've all seen changes in hardware, computers and systems and servers get more powerful, servers in the cloud, software and systems and platforms emerge that are more efficient. In one of your slides, you had a diagram, I think, of the high-performing storage for that valuable data and the less valuable data in kind of raw, I forget the phrase you use, but cloud storage maybe. Maybe over time, is it possible that we're willing to just throw more and more data that we're not sure about its value into more accessible storage as hardware improves, as systems and software get more powerful, just to have it there?
Yes. And let me answer the first part of your question. Will this presentation change over time? I'm absolutely, although I can't look into the future, I'm absolutely certain this presentation will change. Let me tell you a little bit about data warehouse. The first data warehouse I built was not a very good one. And it took me building my first 5 data warehouses before I really started to get a handle on what I knew. When we first built our first data warehouse, it was a data warehouse. It did perform functionally a lot of things to today. Was it well built? No, it was not well built. And so So we're going to learn. This is a learning experience. This is an evolution. So will this presentation change over time? Absolutely, yes. And by the way, in case you're interested, okay, you brought it up, the first data warehouse. A long time ago, we were doing data warehouses, and the vendors of the world and the technicians of the world, out of hand, rejected data warehouse. I have this collection of notes back in my house telling me how stupid I was. I was setting the industry back 25 years, how I was an anarchist. I mean, I got these people were greatly offended by data warehouse. The people that loved data warehouse were the marketing people of the world. And then one day, this company over in Orange County, California, called Pactel Cellular came along, and at that time, cellular telephones were trying to scoop up market share as quickly as they could. And Pactel Cellular came along, and for whatever reason, God loved Pactel Cellular. They're now part of McCall Communications, but Pactel Cellular built a data warehouse. And then what happened was the other cellular telephone companies, management said, hey, we hear that Pactel has got this thing called a data warehouse. So management went down to IT and said, hey, Mr. and Ms. IT, guess what you're going to build? You're going to be building a data warehouse, something they had routinely rejected for years and years. And then right after that, Sam Walton of Walmart wrote a book, and in the book, he mentioned data warehouse. Well, once Sam Walton wrote the book on data warehouse, and he didn't merit the book on data warehouse. Once he mentioned data warehouse in his book, and once the cellular companies were all of them doing data warehouse, then it started to spread across the industry. But the first 3 or 4 years of data warehousing in our industry, you couldn't sell a data warehouse, and so that's the commercial story of how data warehouse spread.
Thanks, Bill. I'm glad that you clarified that, because I thought for a minute that I'd asked the wrong person to come as the father of the data warehouse. I didn't realize it was a Walmart thing, but he gave credence to what you had written. And I think the point you made, if I could summarize, is that that as technologies emerged and evolved, that the types of data that we put in our warehouses and the structures for them has changed, but your definition hasn't changed because it's not technology dependent.
And you know, I never defined anything in my life before that point. And I don't know how I got it right. I really don't, but I did. And the best thing we ever did, the definition data warehouse does not mention technology at all. And that's the way it should be. But that definition, I to this day wonder how that happened, because I wasn't smart enough to do that. And
Well, you're humble. You are smart enough. Even Bill Inmon can understand your most recent book. So thank you for coming to Boise and spending this time with us. We look forward to intermingling for the next time. Thank you for those who joined online. Thanks for the questions. And we just really appreciate all that you've done to our industry, Bill, from 1981 to 2023.
well, thank you, sir. It's been my pleasure.
And you're a kind man on top of it all.
Oh, well, thank you.
All right, thank you.
Thank you.
We have about 15 minutes and then we'll head across.
Oh, can I say one thing?
No.
No. My company is looking, we're developing this program for what we call tech topics or white papers. They're 10 or 15 pages of some topic. It can be about anything related to technology. And we want to publish it for you. There's going to be a small royalty and basis for you. So if you want to write a paper for us, we will protect it with, actually we have some amazing ways to try to protect it. But what kind of papers are we looking for? Data modeling, data vault, technology, you name it. And if you have an idea, you wanted to be a writer, have an idea for a paper, please send it to me, and we would love to have to make you famous.
Does it matter if those have been put on a blog or put on the web prior?
No.
That doesn't preclude them?
As long as they're not copyrighted and as long as you haven't been paid for it.
Okay.
If you've been paid for it, we can't handle it. And as long as the copyright is still available.
Okay.
So anyway, if
For those aspiring authors out there,
aspiring authors,
you have 8 months.
we want to make you famous. Thank you.
Back to you, Rex.
Well, thank you very much. Appreciate Bill coming. I think we'll go ahead and stop the online. Thanks so much.
All right. See, you didn't have to be nervous at all.
Yeah, right.
We didn't throw you any.